Welcome to the sleeping mind and body. This space is designed for rest and gentle learning. You don't need to pay attention or remember anything. Simply listen and let your body settle. If you fall asleep, the video has done exactly what it was meant to do. Inside the body, there is a quiet river that never needs to be noticed in order to keep moving. This river is blood. It flows in a steady, continuous way, carrying small parcels of oxygen and nutrients, collecting waste, and helping each region of the body stay in balance. Most of the time, it does its work without any conscious attention. It moves in the background, calmly and consistently, as if it has all the time it needs. Blood is not a single simple liquid. It is a moving mixture, warm and fluid, made of cells and proteins suspended in a pale, watery medium called plasma. The plasma is mostly water, with dissolved salts, sugars, fats, and many tiny molecules that travel from one place to another. Within this flowing plasma are red blood cells, white blood cells, and platelets. Together, they drift and turn through narrow passages and wider channels, always returning, always circulating. The flow is guided by the circulatory system, which is arranged as a closed loop. Blood travels out from the heart through arteries, passes through smaller and smaller vessels, and then returns through veins. The heart acts as a rhythmic pump, not hurried and not forceful in feeling, just regular. With each beat, pressure gently rises and falls, creating a repeated wave that moves blood forward. It is a cycle that continues without needing a decision, without requiring thought. Arteries carry blood away from the heart, their walls strong and slightly elastic. As the pressure wave travels, the artery walls stretch and settle, helping the flow stay smooth. Farther from the heart, arteries branch into smaller vessels called arterioles, and then into networks of capillaries. Capillaries are very thin, sometimes just wide enough for red blood cells to pass in a single file. Here, the movement slows, and exchange becomes possible. Molecules can move across these thin walls, quietly passing between blood and tissues. Then the blood gathers again. Capillaries merge into small veins, and small veins join into larger veins that guide blood back toward the heart. Veins carry blood with lower pressure, so the movement is steady and calm. Valves in many veins help prevent backflow, making sure the return trip stays organized. The loop continues, one circuit after another, repeating without effort. In this river, red blood cells are the most numerous travelers. They are soft, flexible cells shaped to move efficiently through narrow spaces. Inside them is hemoglobin, a protein that binds oxygen. In the lungs, where air meets blood across delicate membranes, oxygen enters and attaches to hemoglobin. Then the red blood cells carry that oxygen through the arteries, through the capillaries, and toward every tissue that needs it. The process is quiet and automatic. Oxygen loading, oxygen release, and then the return journey for another cycle. As oxygen is delivered, carbon dioxide is collected. Carbon dioxide is a waste product made by cells as they release energy from nutrients. Much of it travels back in the blood, dissolved in plasma or carried in chemical forms that are easy to transport. When blood reaches the lungs again, carbon dioxide moves out, and fresh oxygen moves in. This exchange repeats gently, breath after breath, beat after beat, even when attention is elsewhere. The circulatory system does not only carry gases, it also distributes nutrients. After food is broken down, sugars, amino acids, and other molecules enter the bloodstream and are carried to where they are needed. Some are used immediately for energy. Some are stored for later. The blood can be thought of as a delivery route that reaches everywhere, allowing each cell to receive supplies at the right time, in small continuous amounts rather than in sudden bursts. The river also carries signals. Hormones released from glands travel in the plasma and reach distant tissues, where they help coordinate slow adjustments across the body. Temperature regulation is part of this steady coordination too. By shifting blood flow closer to the skin or deeper within the body, heat can be released or conserved. These are subtle changes, not usually felt, yet constantly managed. White blood cells travel within this same flow, fewer in number than red blood cells, but active in a different way. Some white blood cells patrol the bloodstream, scanning for signs of infection or injury. Others move out of vessels into tissues, then return later through lymph and blood. Their work is quiet protection, a steady watchfulness that does not need to announce itself. Most days, it is simply routine maintenance, a calm readiness. Platelets are smaller fragments that drift along until they are needed. If a blood vessel is damaged, platelets can gather at the site, stick to the injured surface, and help form a plug. Proteins in the plasma support this process, building a stable clot that reduces blood loss while the vessel wall repairs itself. This is natural repair, occurring without drama, often without awareness, a brief moment of organization within the flow. All of these components move together through the same closed loop, guided by pressure, vessel structure, and rhythmic pumping. The heart, the arteries, the capillaries, and the veins keep the river moving. The movement is not random. It is patterned and reliable. Blood returns again and again to the same places, delivering, collecting, and balancing. Even during rest, the river continues. When the body is still, circulation does not pause. The heart keeps its rhythm. Blood keeps moving through the lungs, through the brain, through the skin, through the organs. In sleep, this steady motion remains. The body may change posture, breathing may slow, muscles may relax, but the loop remains intact. Blood continues to carry oxygen. It continues to remove carbon dioxide. It continues to distribute nutrients and maintain temperature. It continues to support quiet repair. There is something gentle about this continuity. A closed loop of vessels, a rhythmic pump, and a flowing mixture of plasma and cells, repeating the same basic route again and again. It is a system designed for steadiness. It does not need applause or attention. It simply moves, like a calm river inside the body, circulating through branching channels, returning, and flowing on. Blood is often described as a fluid, and it is. It moves, it pours, it fills spaces and returns again. And at the same time, blood is also a living tissue, because it contains living cells that travel through the body together. It is a moving mixture, steady and familiar, made of a clear liquid and three main kinds of tiny cellular bodies, all sharing the same current. If you imagine blood close up, the first thing you might notice is the liquid portion, called plasma. Plasma is mostly water, but it is not plain water. It holds dissolved salts, nutrients, hormones, and many proteins that help the body keep its balance. It carries substances from one place to another, not with urgency, but with consistency. Plasma is the background of blood, the calm medium that everything else drifts within. It helps blood stay fluid, helps maintain volume, and provides a gentle environment for cells to travel. Within that plasma, red blood cells are the most numerous travelers. They are small, soft discs, shaped in a way that gives them a lot of surface area for their size. Their main task is quiet and repetitive, carrying oxygen. Red blood cells are filled with hemoglobin, a protein that can bind oxygen in places where oxygen is plentiful and release it in places where it is needed. They move through the circulation in great numbers, each one doing the same simple work over and over without needing attention. The color we associate with blood comes mostly from these red blood cells and the hemoglobin inside them. When hemoglobin holds oxygen, its color shifts slightly brighter. When it has released oxygen, it becomes darker. These subtle changes happen continuously, in a calm rhythm that matches breathing and circulation. There is no single moment when the system begins or ends. It is just ongoing exchange, carried along by flow. White blood cells share the same bloodstream, but they are fewer in number and more varied in form. They are part of the immune system, and their work is protective. White blood cells move through blood and also into tissues, patrolling, sensing, and responding to signs that something does not belong. Some white blood cells swallow and break down microbes and debris. Others coordinate and signal, using chemical messages that guide immune responses. Many are long-lived. Some are short-lived, but together they form a mobile network of quiet surveillance. Even when nothing seems to be happening, white blood cells are still present, still circulating, still ready to shift their attention. They do not need loud alarms to exist. Their protection is often subtle, a steady background activity. They travel in the same plasma as the red blood cells, passing each other in narrow vessels, sharing space with platelets, all moving as one stream with many purposes. Platelets are the smallest of these main components. They are not full cells in the same way, but small fragments that come from larger cells in the bone marrow. Platelets are best known for their role in clotting, which is a kind of natural repair. When a blood vessel is injured, platelets can gather at the site, stick to the damaged area, and help form a plug. They work with proteins in the plasma that can build a stable clot. This process can happen quickly when needed, but it is still controlled, contained, and carefully regulated. Most of the time, platelets simply circulate. They do not form clots without reason. They pass smoothly through vessels, carried by the movement of plasma, drifting beside red and white blood cells. Their readiness is quiet. Their presence is part of the body's way of staying intact, maintaining boundaries, and sealing small breaks when they occur. So blood is made of plasma, red blood cells, white blood cells, and platelets. 4 main parts, always together, always moving. The plasma is the fluid base, the shared space. Red blood cells handle oxygen transport, making sure oxygen can reach distant tissues. White blood cells provide immune protection, sensing and responding. Platelets support repair, helping prevent too much loss when vessels are damaged. Each part has its own role, and none of them works alone. It can be calming to picture how cooperation looks at a microscopic scale. There is no meeting, no planning, no central conversation. There are only countless local interactions, guided by chemistry, shape, and gentle contact. A red blood cell squeezes through a capillary so narrow it must bend. A white blood cell slows near a vessel wall, reading signals from nearby tissue. Platelets drift in the center of flow, then move outward when conditions change. Plasma carries nutrients past them all, and carries away wastes in the same motion. These components are always sharing the same current, like different kinds of boats on the same wide river. Some are common, some are rare. Some have a single repeating task, and others change behavior depending on what they encounter. Yet they do not compete for space in a chaotic way. In healthy flow, They move smoothly, guided by the structure of vessels and the steady pumping of the heart. Plasma, in particular, connects everything. It is the medium that lets oxygen, glucose, amino acids, and signaling molecules dissolve and travel. It also carries carbon dioxide in dissolved forms, and it carries urea and other waste products toward organs that remove them. Many plasma proteins have quiet jobs as well, helping maintain blood pressure, carrying hormones, or supporting clotting when repair is needed. Plasma is both simple and complex, mostly water, but filled with dissolved life. Red blood cells, white blood cells, and platelets do not travel in separate lanes. They move together, side by side, in the same moving volume. At any moment, in any small vessel, there is a mixture. Oxygen carriers, immune protectors, repair-ready fragments, all suspended in plasma. It is a moving community, and its cooperation is built into its design. And this movement continues in every state of the body, including rest, during quiet moments, during stillness, and during sleep. Blood continues to circulate. Plasma continues to carry dissolved substances. Red blood cells continue to load and unload oxygen. White blood cells continue their gentle patrol. Platelets continue their calm passage. The body does not need conscious awareness for these processes to persist. They're steady, self-renewing patterns, repeating with each heartbeat. If you return again to the idea of blood as a living fluid tissue, it becomes easier to hold all four parts in mind at once. A clear plasma that holds and carries. Red blood cells that transport oxygen with hemoglobin. White blood cells that defend and coordinate. Platelets that support repair and clotting. All of it flowing, quietly and reliably, through a network of vessels that reaches nearly everywhere. And as the blood flows, these parts remain together, sharing space and purpose, drifting through the body in a continuous loop. Not rushing toward a finish, not building toward an ending, simply moving and circulating, again and again, in a calm, ongoing exchange. Plasma is the clear, pale fluid that makes up much of the blood's volume. If you could let blood rest and separate, plasma would be the light layer that remains above the cells, quiet and translucent. It is mostly water, and that water gives blood its gentle ability to flow. It moves easily through wide vessels and narrow ones, through steady pathways that reach every region of the body. In that water, many substances dissolve and travel together. There are proteins that remain in the plasma, floating in a calm suspension. Some of these proteins help blood keep its shape as a fluid, helping it stay within the vessels rather than drifting out into surrounding tissues. Some proteins support clotting when a small repair is needed. Others help carry signals or support immune function in a measured, everyday way. They do not rush. They simply remain present, ready to take part in ordinary maintenance. Plasma also holds salts, sometimes called electrolytes. These dissolved particles are small, but their balance matters. Sodium, potassium, chloride, bicarbonate, and others move in the plasma and help keep water distributed properly across the body's compartments. Their concentrations are kept within narrow ranges, not through effort, but through continuous adjustment. Each moment, the kidneys filter and return what is needed. The lungs release carbon dioxide, and tissues exchange fluids. Plasma becomes a moving meeting place where all these exchanges are coordinated. Nutrients travel in plasma as well. After food is broken down, molecules like glucose and amino acids enter the bloodstream and dissolve into this clear current. Fats travel with special carriers, because they do not dissolve in water easily. Vitamins, minerals, and small building blocks for cells drift along in the flow, available to tissues as they pass. The delivery is not dramatic. It is quiet distribution, again and again, with each heartbeat. Hormones also ride in the plasma, released by glands in tiny amounts. They're chemical messages that influence activity in distant tissues. Some hormones travel freely in the watery part of plasma, while others are carried by specific proteins that protect them and extend their time in the blood. Either way, plasma gives hormones a smooth pathway, allowing signals to be shared across the body with calm consistency. At the same time, plasma carries away wastes. Cells produce carbon dioxide as they use oxygen, and much of that carbon dioxide is transported in the blood, often after being converted into bicarbonate. Other waste products, such as urea from the breakdown of proteins, dissolve in plasma and travel toward the kidneys for filtration. Plasma does not judge what is useful and what is waste. It simply holds what is present and brings it to the right place, over and over, in a steady loop. One of plasma's quiet roles is to keep the blood's contents evenly distributed. Red blood cells, white blood cells, and platelets do not travel as separate crowds. They are suspended within this fluid medium, spaced out by motion, kept moving so that no area becomes stagnant. Plasma is the background that allows the cells to be carried, to circulate, and to return again. It is a clear current in which the living parts of blood are gently supported. This clear current also helps the body maintain balance. The acidity of blood, described as pH, stays within a narrow range. That balance depends partly on buffers dissolved in plasma, especially bicarbonate, and partly on breathing and kidney function. With each breath, carbon dioxide levels shift slightly, and with each passage through the kidneys, certain ions are adjusted. Plasma carries these buffers smoothly, helping the inner environment remain stable, not swinging too far in either direction. Temperature is also spread through the body by the blood, and plasma is part of that distribution. Water holds heat well, and the watery portion of blood helps move warmth from regions that generate more heat to regions that are cooler. This helps the body avoid sharp temperature differences inside. Heat is shared gradually, as if carried by a slow stream, smoothing out extremes and supporting an even internal climate. Fluid volume is another aspect of balance, and plasma is central to it. The amount of water in the blood affects blood pressure and the delivery of substances. When the body needs to conserve water, hormonal signals change how much is returned by the kidneys. When more water is available, more can be released. Plasma volume shifts gently, guided by quiet sensing and small adjustments. The result is not perfect stillness, but a stable range, maintained without conscious attention. You can imagine plasma as a clear riverbed that gives shape to movement. It is not empty. It is full of dissolved life. Proteins, salts, nutrients, hormones, and the byproducts of work. And within it, blood cells travel as passengers in a consistent flow. The current does not need to be fast to be effective. It only needs to continue. As blood circulates, plasma passes through the lungs, where gases are exchanged. It passes through the intestines, where nutrients enter. It passes through the liver, where many substances are processed and prepared. It passes through the kidneys, where the composition of the plasma is adjusted by filtration and reabsorption. These organs do their work in cycles, and plasma links them, carrying inputs and outputs in a continuous circuit. Even when the body is at rest, even when the mind is quiet and attention fades, plasma keeps moving. During sleep, The heart continues its steady rhythm, and vessels continue to guide blood along familiar routes. Nutrients still circulate, waste still travels toward removal, hormones still drift to their receptors, and proteins still remain in solution, maintaining the properties of the blood. The clear current continues through the night, neither rushing nor stopping. In the smallest vessels, plasma comes close to cells that line the capillaries and to the tissues beyond. Water and small dissolved substances can shift across these thin boundaries, guided by pressure and concentration. Some fluid leaves the capillaries and becomes part of the interstitial fluid around cells, and much of it returns again, collected by veins and lymphatic vessels. This exchange is constant and gentle, like slow breathing, keeping the space around cells refreshed. Plasma is simple in one sense, mostly water, and yet it carries complexity with ease. It keeps substances mixed and available. It gives blood its fluid continuity. It supports balance in pH, in temperature, and in volume, not as a dramatic task, but as a steady condition. A clear current moving through vessels, again and again, the same pathways, the same quiet circulation. And so the plasma continues, holding and carrying, suspending and distributing, linking one region of the body to another. It is a calm medium for motion, a clear flow that does not need attention to do its work. It moves through the body's branching network like a gentle, persistent stream, never hurrying, never pausing, simply flowing. Red blood cells move through the body in a quiet, steady way, like small travelers carried along by a gentle current. They are among the most numerous cells in the blood, and their main task is simple and constant: to help oxygen reach every part of the body that needs it, moment by moment, without pause. Each red blood cell has a distinctive shape. Instead of being round like a ball, it is shaped more like a soft disc with a slight dip in the center on each side. This biconcave form gives the cell more surface area, which helps it exchange gases efficiently. It also helps the cell remain flexible. Red blood cells are built to bend and fold as they move. They do not need to push or pull. They simply yield to the flow, changing shape as needed. This flexibility matters most in the smallest vessels. Capillaries are narrow pathways that reach deep into tissues, so slim that red blood cells often pass through them in single file. In some places, the capillary opening is smaller than the resting width of a red blood cell. Still, the cell slides through. It softens its shape, lengthens slightly, and continues forward. The motion is smooth and unhurried, guided by the steady pressure of circulation. Inside each red blood cell is a protein called hemoglobin. Hemoglobin is what gives blood much of its red color, and it is also the main carrier of oxygen. Each hemoglobin molecule can bind oxygen molecules in a reversible way. It holds them when oxygen is abundant, and it lets them go when oxygen is less available. This gentle binding and release is not a dramatic event. It is a quiet chemical balance, always adjusting, always repeating. In the lungs, blood passes close to tiny air spaces where fresh air has been brought in with each breath. Even when breathing is slow, even when the body is resting, air continues to reach these spaces. Oxygen moves from the air into the blood by diffusion, drifting from an area where it is more concentrated to an area where it is less concentrated. Red blood cells pass through the lungs' capillaries and take up oxygen as they go. Hemoglobin binds oxygen readily here, where oxygen is plentiful. The red blood cells leave the lungs carrying a calm, full load. From the lungs, this oxygen-rich blood travels to the heart. The heart's chambers guide the flow onward, not as a sudden push, but as a consistent rhythm, steady and repeating. With each beat, blood is sent through arteries that branch again and again into smaller vessels, reaching outward and inward, toward every tissue. The journey does not require awareness. It continues through quiet minutes and through sleep, following the same looping route. As red blood cells arrive in the capillaries of the body's tissues, the surroundings are different from the lungs. Here, cells have been using oxygen. They have been producing carbon dioxide. The local balance of gases is shifting. In these places, hemoglobin begins to release oxygen. It does so naturally because oxygen is needed here and less abundant. The red blood cell does not decide. The chemistry of the environment guides it. Oxygen separates from hemoglobin and moves into the tissue fluid, then into cells. This delivery supports a basic process inside cells, the production of energy. Many cells use oxygen to help convert nutrients into a usable form of energy, a steady supply that supports ordinary functions. Muscles maintain tone. Nerves keep their quiet electrical patterns. Organs continue their work in the background. Even at rest, even in stillness, cells require energy simply to maintain their structure and balance. Oxygen helps make that possible in a continuous, even way. It can be comforting to remember how gradual this is. Oxygen is not delivered all at once. It is offered in small exchanges, across countless capillaries, in a pattern that repeats. Red blood cells move through one capillary bed, release some oxygen, and then continue onward. They pass through veins, which guide blood back toward the heart. From there, blood returns to the lungs again, where hemoglobin can pick up oxygen once more. The loop is simple. Lungs to heart, heart to tissues, tissues back to heart, heart back to lungs. Over and over, a smooth circuit. It does not need to speed up or slow down dramatically. It adjusts quietly to the body's needs, and during sleep it continues in a calm baseline, supporting the brain, the skin, the kidneys, the liver, and every other living tissue. Red blood cells also carry some of the waste gas produced by cells. As cells use oxygen, they generate carbon dioxide. Some of this carbon dioxide dissolves in the blood's plasma, and some is carried in other forms, but red blood cells play a role here too, helping manage the exchange. In the tissues, carbon dioxide enters the blood. In the lungs, carbon dioxide leaves the blood and returns to the air to be exhaled. This exchange is as gentle as oxygen delivery, a quiet balancing act that helps keep the internal environment steady. Through all of this, the red blood cell remains a simple vessel for transport. It has no nucleus, leaving more room for hemoglobin. It does not divide or build complex structures. Its design is focused and practical. To travel, to bend through narrow spaces, to carry oxygen where it is abundant, and to release it where it is needed. If you picture the smallest capillaries, you can imagine the soft pause of exchange happening there. A red blood cell glides past a tissue cell, close enough for oxygen to drift across. Then it continues, making room for the next one. Millions of these passages happen each second, but they do not feel like motion from the inside. They are part of a background flow, steady and reliable. And so the cycle continues, quietly. The lungs offer oxygen. Hemoglobin receives it. The heart guides the blood onward. Tissues accept what they need. The blood returns again, ready to repeat the same calm loop. Even in rest, even in sleep, red blood cells keep moving, bending gently through narrow capillaries, carrying oxygen as a soft, steady delivery, again and again, in an unbroken rhythm. As blood moves through the smallest vessels of the body, it does not only bring things outward, it also receives what is ready to come back. In the tissues, after oxygen has been used inside cells, another gas becomes more common. Carbon dioxide forms as a natural result of steady chemical work. It is not a sign of trouble. It is simply what remains when cells release energy from nutrients, one quiet step following another. Carbon dioxide gathers in the fluid around the cells, and from there it drifts into nearby capillaries. The walls of these tiny vessels are thin, made for exchange. There is no need for forceful movement. There is a gentle difference in concentration, and molecules follow that difference. So carbon dioxide moves from the tissues into the blood, joining the stream that is already flowing. Once inside the blood, carbon dioxide can travel in a few calm and ordinary forms. Some of it stays dissolved in the plasma, like a gas held in water. Some binds to hemoglobin inside red blood cells, not in the same place as oxygen, but in a way that allows it to be carried. And much of it is converted into a related form, bicarbonate, which mixes easily in the plasma. Different forms, same purpose. A smooth return, a quiet transport, a steady movement back toward the lungs. This return journey follows the same simple pattern throughout the body. From capillaries, blood moves into small veins, then into larger veins, gradually collecting into a broader current. It is a slow gathering. It does not rush. It simply continues, carried by the gentle pressure of the heart and guided by valves that help keep flow moving in one direction. Outward and inward, again and again. Delivery outward, return inward. A repeating exchange that stays mostly unnoticed. When this returning blood reaches the lungs, the pattern reverses once more. The lungs are filled with tiny air sacs, each one closely wrapped in capillaries. Here the blood passes near fresh air. Oxygen is ready to move into the blood, and carbon dioxide is ready to leave it. The same principle applies. Molecules drift along gradients, from where they are more concentrated to where they are less concentrated. No dramatic change is needed. Just contact, thin membranes, and time. Carbon dioxide moves from the blood into the air spaces of the lungs. Then, with a slow exhalation, it is released into the outside air. It leaves quietly, breath after breath, whether the breath is deep or shallow, whether it is noticed or not. In this way, the body keeps its inner chemistry balanced. It adds oxygen. It lets carbon dioxide go. It repeats the exchange in a calm cycle that continues in the background. And carbon dioxide is not the only thing that returns. As blood passes through tissues, it also picks up other small leftovers of daily activity. These are ordinary byproducts of living cells, fragments and compounds that are no longer needed in that moment. They enter the plasma and travel along with the flow, not as an emergency, but as routine housekeeping. Some of these wastes are carried toward the liver, where many substances are processed and adjusted. Some travel to the kidneys, where the blood is filtered and the balance of water and salts is carefully managed. Some move through other pathways, handled gradually as the blood keeps circulating. The details can be complex, but the feeling of the system is simple. Blood goes out carrying supplies. Blood comes back carrying what should be removed or reshaped. The same calm circulation supports both directions. It can help to imagine the bloodstream as a quiet river with two kinds of cargo. On the outward side, it brings oxygen and nutrients, steady and dependable. On the inward side, it carries carbon dioxide and other byproducts back toward places designed to release them or transform them. Not a struggle, not a contest. Just transport. Just balance. This is happening in every region of the body, at slightly different rates, in slightly different mixtures, depending on what each tissue is doing. Muscles at rest produce less carbon dioxide than muscles in motion, but they still produce some. The brain, always active in its own way, produces its share as well. Every cell participates in the same basic exchange, taking in what it needs, letting go of what it has used. In the smallest vessels, where exchange is most direct, the movement is gentle and local. Oxygen leaves the blood and enters tissues. Carbon dioxide leaves tissues and enters the blood. Nutrients move outward. Byproducts return inward. Then the blood continues on, carrying its new mixture through veins, through the heart, and onward to the lungs and filtering organs. The heart does not need to think about this. It contracts and relaxes, creating a rhythm that keeps blood moving. In the lungs, gases trade places with quiet efficiency. In other organs, dissolved substances are filtered, processed, and balanced. The body does not pause to announce these tasks. It simply performs them continuously. Even in rest, even in sleep, this exchange continues. Breathing may become slower and softer, yet carbon dioxide still transfers from blood to air with each exhale. The circulation may feel more settled, but it does not stop. Blood still passes through capillaries. Cells still use oxygen. Cells still produce carbon dioxide. And the bloodstream still carries it back, in dissolved form, in bicarbonate form, and bound gently to hemoglobin, all moving toward release. So the pattern stays steady. Outward delivery, inward return. Oxygen outward, carbon dioxide inward. Nutrients outward, byproducts inward. Again and again, in a loop that is calm enough to fade into the background of awareness. In this quiet river of blood, waste transport is not dramatic. It is simply part of being alive. Carbon dioxide is gathered, carried, and released. Other small leftovers are collected and guided toward organs that can handle them. The blood does not judge this cargo. It carries what is needed, then carries what is no longer needed, and it keeps going. A slow exchange in tiny vessels. A gentle return through veins. A soft release in the lungs. A steady processing elsewhere. The same motion repeating, maintaining the internal environment with little sound and no ceremony. The body breathes out what it has finished with, and the blood continues its quiet route, outward and inward, as the steady circulation flows on. Within the steady movement of blood, there is another kind of traveling cell, fewer in number than the red blood cells, but quietly important. These are the white blood cells. They move along with the circulation, carried through wide vessels and fine capillaries, passing through familiar routes again and again. Most of the time, they are simply present, part of the background of normal life, drifting through the body in a calm, watchful way. White blood cells are not mainly focused on carrying oxygen. Their work is more about recognition and response. They help the body notice what belongs and what does not, in the same way that the bloodstream touches almost every region. White blood cells have access to many places, and they can move from the blood into nearby tissues when it is useful. They do not stay confined to the inside of vessels. When needed, they can slow down, adhere gently to the vessel lining, and pass through the thin wall, entering the spaces between cells where quiet maintenance continues. Because they are fewer in the blood than red blood cells, It can be easy to imagine them as rare visitors, yet they are consistently there. A small number is enough for steady surveillance, because they are always in motion, always circulating, and always being replaced. Some are made in the bone marrow. Some mature in other tissues. Over time, they move through blood, lymph, and the small hidden corridors of the body, linking one region to another. A simple way to think of their role is that white blood cells help keep the internal environment orderly. They can recognize patterns associated with microbes, and they can also respond to signals released by the body's own cells. When a cell is stressed, damaged, or infected, it may release chemical messages into its surroundings. Those messages diffuse into nearby fluid, and some of them reach the blood. White blood cells can respond to these signals by changing their movement, gathering more in a particular area, and adjusting what they do. Much of this happens quietly, without any clear sensation. It is a low-level attentiveness present in the background. Most days, most moments, there is nothing dramatic to notice. White blood cells simply circulate, sample the environment, and continue on. This quiet monitoring is part of how the body stays stable, even as it interacts with air, food, surfaces, and countless small particles in the world. There are different kinds of white blood cells, with slightly different roles. Some are good at taking in and breaking down small debris, including worn-out cell parts or microbes that have entered the body. These cells can surround a particle, bring it inside, and gradually digest it, reducing it to simpler components. Others focus more on recognition and communication. They help coordinate responses by releasing signaling molecules that guide nearby cells. Some support the production of antibodies, proteins that can bind specific targets with a precise fit. Even when these details remain unseen, the overall effect is a calm organization of information and activity. This process is not only about microbes. Normal life produces constant small fragments that need to be cleared. Cells age. Proteins are broken down and rebuilt. Tiny injuries occur in the ordinary use of muscles and skin and lining tissues. White blood cells are part of the routine cleanup. They help remove what is no longer needed so that tissues can stay clear and functional. In this sense, they are as much about balance as they are about protection. In the bloodstream, white blood cells travel in a way that differs slightly from red blood cells. Red blood cells tend to flow in the center of the vessel stream, carried smoothly along. White blood cells, being larger and shaped differently, often travel closer to the vessel walls. This position makes it easier for them to interact with the lining of the vessel, and easier to pause when signals from the tissues suggest that attention is needed nearby. It is a small detail, but it matches their role, not just passing through, but staying ready to step out. When a white blood cell leaves the blood to enter tissue, it does so carefully, moving through the vessel wall in stages. It slows, it rolls along the inner surface, it attaches more firmly, and then it passes between the cells that form the vessel lining. This is not a sudden break or tear. It is a controlled passage, guided by chemical cues and physical contact. Once outside, it moves through the tissue fluid, navigating by gradients of signals, toward the area where it can help. And then, when the moment is complete, many white blood cells simply continue on, or they complete their tasks and are eventually removed as part of normal turnover. The body constantly produces new white blood cells, balancing loss with renewal. The system does not depend on a single cell, but on ongoing continuity. Many cells doing small amounts of work, over and over, keeping conditions steady. It can be calming to remember that this watchfulness does not switch off. During rest, when breathing slows and muscles soften, blood continues to circulate. The heart still provides a gentle pressure that moves plasma and cells through the vessels. White blood cells still pass through the same pathways, still drifting, still sensing chemical surroundings. Sleep changes many things, but it does not end this quiet monitoring. If anything, rest can support it, because the body has time to focus on maintenance with fewer interruptions from movement and activity. Even in sleep, the boundary surfaces of the body remain in contact with the world. The lungs continue to exchange air. The digestive tract continues its slow processing. The skin remains a calm barrier. In these places, immune cells are present, not tense, not urgent, simply available. They maintain a steady readiness, like a background system that checks, recognizes, and returns to calm. White blood cells communicate with one another and with many other cells. Their messages are chemical, traveling through fluid, binding to receptors, and changing what cells do next. The signals can be local and small, affecting only a tiny region, or they can spread more broadly when needed. Often, the outcome is subtle. A slight increase in attention in one area, a bit more cleanup, a gentle change in traffic through nearby vessels. The body makes adjustments in quiet increments. At the same time, the immune system learns and remembers. Some white blood cells can persist as memory cells, carrying information about past encounters. This memory does not require conscious effort. It is stored in cellular patterns, in the readiness to respond more smoothly if something similar appears again. Even that memory can be thought of as quiet structure, held within living cells, traveling within the larger river of blood. So, within the constant flow, white blood cells continue their calm routine. They move, they pause, they listen to chemical signals, and they help clear what does not belong or what is no longer useful. They support tissues not through forceful effort, but through steady presence. They are part of a system that stays active without needing attention. And as the circulation repeats its loops, through the heart, through arteries, through capillaries, and back through veins, white blood cells repeat their own loops as well, returning again and again, making gentle checks, and continuing onward. In this way, protection is less a dramatic event and more a quiet condition, maintained moment by moment, through rest and through sleep, in the soft continuity of the bloodstream. Inside the steady movement of blood, there is also a quiet system for small repairs. Most of the time, blood travels smoothly through open pathways, sliding along vessel walls without sticking, keeping its motion calm and uninterrupted. And yet, if a tiny vessel is scratched or a small opening appears, the blood can shift gently from flowing to sealing, only in that local place, only for as long as it is needed. One of the first helpers in this careful response is the platelet. Platelets are not full cells. They are small fragments, released from larger cells in the bone marrow, and carried throughout the circulation in large numbers. In normal flow they remain inactive, drifting with the current. They do not seek out trouble. They simply pass through, again and again, ready but quiet. When a vessel wall is intact, its inner lining presents a smooth surface. Blood cells and platelets move along it without catching. But when there is a break in that lining, the underlying materials are exposed. The change is subtle, but it is enough to signal that this spot is different. In that moment, platelets begin to slow and make contact. They adhere to the damaged area, as if recognizing a surface that is no longer sealed. As a few platelets attach, they change shape. They become more spread out, with small extensions that help them hold on. They also release gentle chemical signals that invite nearby platelets to join them. This is not a sudden crowding everywhere in the body. It is a local gathering, limited to the small region where the vessel needs to be closed. The platelets collect, layer by layer, forming a temporary plug. This first platelet plug is like a soft barrier. It can reduce bleeding quickly, especially in very small vessels. It is not yet a strong seal. It is a first step, simple and direct, covering the opening so that the flow can slow down in that one place, while the rest of the blood continues its steady passage through the wider network. While platelets are gathering, another process begins in the surrounding plasma. Plasma is the liquid part of blood, and within it are many dissolved proteins. Among these proteins are clotting factors, molecules that can interact in an ordered sequence. They circulate quietly in an inactive form, present but not interfering with normal flow. They remain mostly unnoticed because most of the time they are not needed. At a site of injury, the conditions change. Signals from damaged tissue and from activated platelets help begin a chain of reactions. One clotting factor activates the next, and then another, step by step. This sequence is sometimes called a cascade, not because it is dramatic, but because it proceeds in a measured progression, each step preparing the next one. The end result of this sequence is the creation of a strong, thread-like protein called fibrin. Fibrin forms long strands that weave through and around the platelet plug. If the platelet plug is a quick covering, the fibrin network is the stabilizing layer that makes the seal more durable. The mesh holds platelets and blood cells in place, turning a loose gathering into a stable clot. Even here, the body remains careful. The clot forms where it is needed, at the opening, and it stays limited by balancing signals that keep clotting from spreading into open, healthy vessels. Blood is meant to remain fluid and moving. The repair is meant to be specific and contained. In a body at rest, in a body that is asleep, the same principles apply. The flow continues, and only a small region is asked to pause and seal, if a pause is required. As the clot settles, the vessel wall begins its own slow work of rebuilding. The initial goal is simple: stop the loss and protect the area. After sealing comes stabilizing, and after stabilizing comes gradual remodeling. Cells in the vessel wall can migrate and multiply to restore a smooth inner surface. Over time, the fibrin mesh is broken down and removed in a controlled way, and the temporary structure is replaced by repaired tissue. This remodeling is unhurried. It does not need constant attention. It proceeds quietly in the background while the rest of circulation continues its looping path. Heart to arteries, arteries to smaller vessels to veins, and back again. With each heartbeat, the blood keeps moving, and with each breath, oxygen continues to be carried, even while these small repairs happen in their own time. It can be helpful to picture platelets as small, patient tools, carried everywhere but used only when a surface is no longer smooth. They do not block the normal pathways. In healthy vessels, they remain unobtrusive, moving along with red blood cells and white blood cells through the gentle currents of plasma. And it can be helpful to picture clotting proteins as a set of quiet ingredients, already present in the liquid of blood, waiting in an inactive state. When the right conditions appear, only at a local break in the vessel lining, those ingredients can be combined through a sequence of steps, forming fibrin strands that strengthen the seal. Sealing, stabilizing, remodeling. A small local pause, then a gradual return to smooth flow. This is the calm pattern of natural repair. Most of the time, nothing needs to be sealed. Most of the time, blood remains smoothly flowing and unobstructed, moving through vessels that are lined and intact. Platelets drift without gathering. Clotting factors remain inactive, simply part of the plasma, dissolved and ready but quiet. In rest and in sleep, circulation continues. The heart keeps its steady rhythm. Blood continues to glide through the body's branching roots. Oxygen is carried, nutrients travel, wastes are collected, and heat is distributed. And alongside this steady movement, the body maintains the ability to make small, precise repairs, briefly forming a plug, building a stable clot, and then slowly restoring the vessel to a smooth inner surface, so that the quiet river of blood can keep flowing, clear and continuous. Inside the body, blood moves through a wide, branching set of pathways. These pathways are the blood vessels, and they form a quiet network that reaches outward from the heart and returns again. Some vessels carry blood away, some bring it back, and some are so small that exchange can happen gently, cell by cell, molecule by molecule. Together, arteries, veins, and capillaries make a continuous route, a kind of living map that is always present, always open. Arteries are the vessels that carry blood away from the heart. With each steady beat, blood enters these vessels and travels outward, following larger channels at first, and then smaller branches. Arteries have firm, elastic walls. That elasticity allows them to stretch slightly as blood arrives, and then ease back, helping the flow remain smooth rather than abrupt. This outward movement is not hurried. It is consistent. It is simply the normal direction of travel, from the heart toward the tissues. As arteries branch, their pathways narrow and divide again and again, like a tree whose limbs become twigs. Each branch guides blood toward a specific region. Some branches lead toward the head and brain, some toward the muscles and skin, some toward the organs that quietly sort, store, and balance the body's chemistry. The path is organized without being loud. It is a stable pattern that repeats, moment after moment, even when the body is resting. Eventually, the smallest arterial branches give way to capillaries. Capillaries are the tiniest vessels in the network, so narrow that red blood cells often pass through in single file. Their walls are thin, designed for exchange rather than force. In capillaries, blood slows. The pace becomes gentle, and this slower movement creates time for substances to move between blood and tissue. This exchange happens largely by diffusion, a natural drifting of molecules from where they are more concentrated to where they are less concentrated. Oxygen, carried by red blood cells, is more abundant in the blood arriving at active tissues, and less abundant in the cells that are using it. So oxygen tends to move outward, leaving the blood and entering the surrounding tissue fluid, then passing into cells. At the same time, carbon dioxide, produced by cells as they release energy, is more concentrated in the tissues than in the incoming blood. So carbon dioxide tends to move inward, slipping into the capillaries to be carried away. Nutrients follow similar quiet rules. Glucose and amino acids, small building blocks and fuel, can drift from capillary blood into tissues where they are needed. Water and dissolved salts also shift back and forth, helping maintain balance in volume and pressure. Some substances move through pores between cells of the capillary wall, and some pass directly through the cells that form the wall. It is a controlled permeability, not a leak, not a spill. It is a careful openness that allows exchange without losing the structure of the circulation. In many places, capillaries form dense beds, a delicate mesh that increases the surface area for diffusion. A single small region of tissue may be surrounded by many capillaries, ensuring that nearly every cell is close to a blood supply. No cell needs its own vessel. Instead, the network comes near, and the final distance is crossed by diffusion through fluid that fills the spaces between cells. This last step is quiet and local, happening without any sensation, continuing whether a person is awake, resting, or asleep. After capillaries, blood begins its return journey through venules, small vessels that gather blood leaving the capillary beds. Venules merge into larger veins. Veins carry blood back toward the heart, bringing along carbon dioxide and other dissolved wastes, along with blood that has delivered some of its oxygen and nutrients. The direction has changed, but the continuity is the same. Outward, then inward, in a repeating loop. Veins are built differently from arteries. Their walls are thinner and less muscular, because the pressure in veins is lower. The blood in veins is still moving, still guided, but with less force behind it. To support this return flow, many veins, especially those in the limbs, contain valves. These valves are small folds of tissue inside the vessel that open to let blood move forward, and then close to help prevent it from slipping backward. They do their work silently, shaping direction without effort and without awareness. The movement of nearby muscles can also assist venous flow. As muscles contract and relax during ordinary shifts in posture and small motions, they can gently compress veins, helping push blood along. This is not something that needs attention. It is simply part of how the body is arranged, with vessels placed among muscles and tissues that naturally move from time to time. Even during sleep, when movement is minimal, the heart continues to provide the steady push that keeps the entire circuit active, and the valves continue to guide the return. In the chest, breathing can also influence venous return in a subtle way. As the lungs expand and contract, pressure changes gently inside the thorax, and these changes can help draw blood back toward the heart. It is another example of systems sharing space and supporting one another, not as a dramatic partnership, but as a quiet coordination that has been built into the body's structure. Throughout all of this, the vessel network remains widespread and intimate. Larger arteries and veins are only the visible trunks of a much finer pattern. The true reach of circulation is in the countless small branches, the capillary beds woven through muscle fibers, through the lining of organs, through the skin, through the tissues that support nerves and glands. The network is everywhere, not as a single line, but as an evenly distributed presence. Blood vessels do not only transport, they also help regulate where blood goes. Small arteries and arterioles can narrow or widen, adjusting flow to different regions based on local needs. This adjustment is gradual and automatic. It helps match delivery with demand, keeping temperature, chemistry, and oxygen supply within stable ranges. The changes are usually modest, a gentle tuning rather than a sudden switch. And then the pattern returns again: arteries outward, capillaries for exchange, veins inward. Oxygen offered, carbon dioxide collected. Nutrients delivered, wastes gathered. A loop that does not require attention, a system that does not pause for sleep. In the quiet hours, as awareness softens, the vessels continue their work. The arteries still carry blood away from the heart. The veins still guide it back. The capillaries still allow diffusion, slowly and precisely, sustaining every region with the same steady patience. In this way, the vessels form a calm geography within the body. pathways large and small, arranged to reach every tissue. A circulation that is continuous and balanced, repeating and repeating, like a river branching into streams and returning again, carrying life through the body in an even, unbroken flow. Inside the chest, the heart keeps a simple rhythm. It does not rush, and it does not pause for long. It tightens and releases in a steady cycle, and with each tightening, it creates a gentle rise in pressure. That pressure moves outward into the vessels as a traveling wave, like a soft pulse that can be felt far from where it began. The blood does not leap forward all at once. It is guided along by these repeating waves, encouraged forward, then allowed to settle, then encouraged again. Each beat is a small change in pressure, and each change helps blood move through branching paths. Larger arteries accept the first push, and their elastic walls stretch slightly, then ease back. In this way, the pulse becomes smoother as it travels, turning sharp motion into a calmer flow. The circulation is not one hard push followed by emptiness. It is more like a repeated pressing and releasing, over and over, so the blood can keep traveling without interruption. Blood pressure is one name for this quiet force. It is not constant, but it is steady enough to be reliable. It rises a little with movement and falls a little with rest. It shifts with breathing, with posture, with temperature, and with the ordinary changes of a day. These adjustments are usually subtle, the kind of changes that happen without being noticed. The body maintains a useful balance. Enough pressure to move blood through distant tissues, and enough gentleness to protect the delicate exchange taking place in the smallest vessels. As the day unfolds, the heart and vessels respond to what is happening. During activity, the rhythm often becomes a little quicker, and the pressure wave may come a little more often, helping send blood toward working muscles and warm skin. During quiet moments, the rhythm often slows, and the waves arrive with more space between them. The blood still moves. Even when the body is still, circulation continues, carrying oxygen, carrying nutrients, carrying heat, carrying dissolved signals, and returning with carbon dioxide and other wastes, ready to be processed and released. At night, patterns usually become common. With rest, the nervous system shifts toward a quieter setting. The heart often beats more slowly. The pressure in the arteries often drifts lower than it was during the day. The vessels may relax, allowing a smoother passage. It is not a shutdown. It is a gentle adjustment, a change in tone rather than a change in purpose. Blood continues to travel in loops. Out from the heart, through arteries, into smaller branches, through capillaries where exchange happens, and back again through veins. In the capillaries, the pulse has mostly softened. The movement here is slow and close, suited to the work being done. Oxygen leaves the red blood cells and moves into nearby tissues. Glucose and other small molecules pass from plasma into cells. Water shifts in and out according to pressure and concentration. Meanwhile, carbon dioxide moves from tissues into the blood, and other waste products join the flow. This exchange is constant, quiet, and local, happening in many places at once, with no need for awareness. After exchange, the blood begins its return. Veins gather flow from many small paths into larger ones. The pressure in veins is lower than in arteries, but return is steady. The body uses several simple supports: the gentle squeezing of muscles, the changing pressure of breathing, and one-way valves that prevent backflow in many veins. Even in rest, breathing continues, and with each inhale and exhale, pressure changes in the chest help guide blood back toward the heart. The cycle completes and begins again. Carry, exchange, return, repeat. During rest, blood is also redistributed in a quieter pattern. More flow is kept steady toward organs that must work continuously. The brain, which maintains awareness even in sleep. The heart itself, which receives its own blood supply through coronary vessels. The kidneys, which filter plasma and adjust water and salts. The liver, which processes nutrients and manages chemicals. The intestines may continue their slower movements, supported by an ongoing supply. The skin continues to receive blood for temperature balance, though the amount may shift as the body cools slightly in sleep. This redistribution is not dramatic. It is a gentle prioritizing, guided by the widening and narrowing of small arteries and arterioles. A vessel can relax to allow more flow, or tighten to allow less. These small changes help match supply to need. They happen automatically, guided by local signals from tissues and by broader signals from the nervous and hormonal systems. The overall effect is calm coordination, allowing blood to move where it is most useful, then to move on. Even the heart's own rhythm is shaped by these quiet controls. Sensors in blood vessels detect pressure and adjust the balance between speeding up and slowing down. Chemical signals in the blood reflect levels of oxygen and carbon dioxide, and the body responds with fine-tuning. The goal is simple and steady. Maintain circulation, maintain exchange, maintain the internal conditions that cells need. The heart does not need to think about it. The vessels do not need instruction. The pattern is built into the system. If you imagine the circulation as a river, it is a river with many branches and returns. The heart is not a loud engine but a rhythmic source of pressure, sending waves along flexible tubes. With each beat, blood is moved forward. Between beats, the vessels continue to guide the flow. The rhythm repeats without announcement. The pressure rises, then eases. The blood travels outward, then returns inward. Carry, exchange, return, repeat. In sleep, this rhythm continues in a quieter register. The body is not idle. Cells still use oxygen, still produce carbon dioxide, still take in nutrients and release wastes. Repair processes continue, built from ordinary materials delivered by the blood. Immune cells continue to circulate, passing through the bloodstream and into tissues, then back again, scanning calmly without urgency. Platelets drift in the plasma, ready for their usual role in sealing small damage if it occurs. Plasma continues to carry proteins, salts, and dissolved compounds, holding volume and providing a stable medium for transport. The heart's pulses keep coming, one after another, and the circulation keeps forming its loops. Blood moves through the lungs, where carbon dioxide is released and oxygen is taken up. Blood moves through the body, where oxygen is offered and carbon dioxide is collected. Blood moves through the kidneys, where filtration continues. Blood moves through the liver, where processing continues. It is a repeated, reliable motion, not aiming toward an endpoint, only maintaining the present moment. The pattern can be returned to again and again. A beat, a wave, a forward movement. A slower flow in capillaries, a quiet exchange. A steady return through veins, and then again. Carry, exchange, return, repeat. In daylight or darkness, in motion or stillness, the rhythm continues, gentle and balanced, supporting the body with continuous circulation. As the body rests, the blood continues its quiet movement. Sleep does not switch the circulation off. It simply changes the pace and the pattern, like a river that flows a little more slowly at night, still reaching every bend and every shore. With each gentle heartbeat, blood keeps moving through arteries, through narrower and narrower vessels, and then back again through veins, returning to the heart to be sent onward once more. Even in sleep, oxygen is still needed. Cells in the brain, in the muscles, in the skin, and in every internal organ continue their steady work. They release and store energy, maintain their structures, and keep their internal chemistry balanced. Red blood cells carry oxygen through this resting landscape. Inside each red blood cell, hemoglobin holds oxygen and releases it where it is needed, then returns to the lungs to gather more. The exchange is constant and quiet. Oxygen in, carbon dioxide out, again and again, with no need for attention. Plasma, the pale liquid portion of blood, continues to be a moving environment. It carries dissolved salts and proteins, nutrients from digestion, and hormones that help coordinate the body's rhythms. It also carries away the byproducts of living, small molecules that must be transported to the liver, the kidneys, the lungs, and the skin for processing and removal. During rest, this transport continues smoothly. The blood does not wait for waking. It keeps delivering what is useful and carrying away what is no longer needed. In the smallest vessels, called capillaries, blood slows down, and exchange becomes easier. Oxygen slips from red blood cells into surrounding tissues. Carbon dioxide and other wastes slip back into the blood. Water and dissolved substances shift gently between blood and cells. This is one of the most quiet and constant events in the body, happening everywhere at once. A slow, even sharing. A steady trade that keeps the internal environment stable. White blood cells continue their calm work as well. They move through the blood, but also pause and travel into tissues, checking for signs of infection or damage. Most of the time, in a healthy body, there is no emergency to respond to. The immune system's activity is often more like monitoring than fighting, more like looking than attacking. White blood cells circulate, sample their surroundings, and communicate using small chemical signals. Even during sleep, this watchfulness continues in a balanced, low-key way. Platelets move along with the flow, small and ready, without needing to be called upon. Their role is simple and protective. If a blood vessel wall is disrupted, platelets can gather and help form a seal. In rest, in the dark quiet of sleep, platelets continue to circulate, passing through the same pathways again and again. Most of the time they do nothing noticeable. Their readiness is part of the body's steady safety, a natural repair system kept in place without effort. The four main components, red blood cells, white blood cells, platelets, and plasma, remain together in a repeating loop. Plasma carries cells and dissolved materials. Red blood cells transport oxygen and help remove carbon dioxide. White blood cells patrol and respond when needed. Platelets support repair. The heart provides pressure and rhythm. The blood vessels guide the flow. And the tissues quietly receive and return in a continuous exchange. During sleep, the body also maintains temperature. Heat is produced by metabolism, even when movement is minimal. Blood helps distribute that heat, carrying warmth from deeper tissues toward the skin, where it can be released, or holding heat in the core when needed. Blood vessels can narrow or widen slightly to adjust this balance. These changes are subtle. They happen without conscious thought, guided by the nervous system and by chemical signals in the blood itself. The breathing pattern changes during rest, becoming slower and more regular for many people. Still, with each breath, oxygen enters the lungs and passes into the bloodstream. Carbon dioxide leaves the blood and is exhaled. Red blood cells continue their constant cycle. Lungs to heart to tissues and back again. The route is familiar, repeated countless times. A soft loop with no beginning and no end. Energy supply continues as well. Cells rely on glucose and fatty acids, and on the careful balance of ions and water. Plasma carries nutrients from the digestive system, even hours after eating, and from stored reserves when needed. The liver adjusts the levels of sugars and other molecules. The blood serves as the connecting pathway, moving these materials to where they are used, and taking away the leftovers of chemical reactions. Waste removal stays active through the night. The kidneys filter plasma, removing excess water, salts, and small waste molecules, producing urine. The liver modifies and packages other waste products for elimination. Carbon dioxide is carried back to the lungs. The blood is the transport system that links these organs to every cell, making removal steady rather than sudden, gradual rather than dramatic. In this resting state, repair and renewal continue at a gentle pace. Tiny damages in tissues are addressed. Proteins are replaced. Cells renew parts of themselves. Blood supports this by bringing building materials, oxygen, and signaling molecules, while also removing waste that would otherwise accumulate. Platelets remain present as a quiet safeguard. White blood cells remain nearby as calm observers. Red blood cells keep delivering oxygen with a consistent reliability. The flow is not the same everywhere at the same time. Some regions receive more blood depending on need, and that need shifts with sleep stages and with normal changes in the nervous system. Yet the overall pattern remains smooth and continuous. A network of vessels, branching and rejoining, guiding blood through the body like water through a wide, connected landscape. It can be soothing to remember how much of this happens without effort. The heart keeps its rhythm. Blood keeps its route. Plasma keeps carrying. Red blood cells keep exchanging gases. White blood cells keep their measured surveillance. Platelets keep their quiet readiness. Oxygen arrives. Carbon dioxide returns. Heat is shared. Nutrients move out. Wastes move in. Again and again, with small variations, but always within a stable range. And as sleep continues, the circulation continues too, steady and patient. The blood does not hurry. It does not pause. It moves through the same familiar pathways, returning, turning, passing, and returning again. A quiet river of life, flowing through rest as easily as through waking, carrying what is needed, taking what is no longer needed, and simply continuing on.